simplified fractions. For instance, we had something like this. 6/15 simplified. Now that meant we wanted to get smaller numbers from that fraction, right? What did we do? Go ahead, brother.
Divide.
We divided. Something will divide out of 6 that will also divide out of 15. What was it?
3.
3? Dylan, 3? We all agree with 3. You like 3, Cole? So divide by 3, divide by 3. 6 divided by 3. 2. 15 divided by 3. 5. There, more people knew that one. Okay, good. So did we make this more simple?
Yes,
Yes, we did. That was last week, simplifying. All right? That was one thing we did. Another thing we did was we looked at equivalent fractions like this right here. And there was a blank in the other fraction. How do we find what's in that there blank?
Times it by 3.
But we times every fraction by 3?
No.
No.
Sometimes you have to divide.
So, what did we learn last week that you'll never find in a math book? It's something I made up. What do you think there, Haney? PhD. Remember PhD? Play, how, did. So, how did 8 turn into 24? It got times by 3, so we do the exact same thing to the bottom. 10 times 3?
30.
And we found the missing part to the equivalent fraction, or the equal fraction to it. Remember doing that? PhD. Is it coming back to you?
Yes, sir.
I know some of y'all slept this weekend and you laid your head down and all that stuff I taught you leaked out on your pillow. Like y'all drooling or something. So, that was PhD. Do you remember taking last week a mixed number and changing it into a fraction that numerator was bigger than its denominator? Brother Jones.
You multiply 3 times 5.
What do we call it? Another one of them Jordan things that you won't find in the math book. Loopy loop. Loop times. You go with me? Loop times.
Plus.
Loop times
5,
15. Good. Now that loop plus
2,
17.
17. And what did we do with that 17 we got?
You put it on the top of the
Put it on top in the numerator. 17. Oh, I ain't got no bottom. Woo! Gotta have a bottom. Gotta have a denominator. What do you think, Haynes?
The original 5.
The original denominator 5 slides over there improper. Awesome job. What was the last thing we did last week? Last thing. Or the thing I haven't discussed yet.
Improper fractions into
Mixed.
mixed.
Good job. Start with a big top thing like this right here. That's an improper. Can we turn it back into a big number with a fraction?
yes.
What did we do with that? Oh, no, put it there. No, I know Sarah. Michaela. Michaela. What do we do, girlfriend? Divide the bottom into the top. Alright? So we're thinking mental math, remember? Tony, remember we're doing mental math. How many 6s can we take out of 19? Daniel? 3. So what do we do with that 3? That's our big number, isn't it? That's our big whole number. 3 6s will make close to 19. Does it make exactly 19?
No, sir.
What does 3 6s make? 18. So how many leftovers do I have from the 19?
1 and 6.
1. So where's that 1 go?
Top.
On top, up. I ain't got no bottom. Woo! I need a bottom. Original 6 denominator comes over there mixed number. Now that was last week. Did you jog your memory? Remember it?
A little bit.
No little bit, you better remember it. Because what's happening Wednesday? Test. You wrote it in your planner. We're going to be testing on this stuff. Alright, some little birdie said, well, Pop, where's the mark? Oh, okay. So, let's go to today's stuff. Alright, here we go. So you got this already written, ready to go, right, brother?
Not comparing ordering.
Uh-oh. That's what we're doing today, dude. You're supposed to already have that written. Today we're going to compare fractions. Comparing and ordering fracts. Want to leave that off so you can, now we can put it on there. We're going to compare and order fracts. What's fracts? Fractions. Yeah, that's our abbreviation. Fractions. Well, folks, I need to know what comparing means. Comparing something. Comparing something. Yes, Sister Sarah.
It's when you compare something to another thing.
Right, but you use the word compare in the definition for compare. Now let me give you an example. Me and Alec. Is that right, Alec? Me and Alec. All right, let's compare me and Alec. Here we go. He's ugly and I'm good looking. That's a comparison. All righty? He's kind of a little guy, I'm kind of a big guy. He's kind of a young guy, I'm kind of an old guy. That's comparing, correct? We also compare in mathematics. Compare in mathematics is a, Tony, we're writing, dude, is a number. If you keep looking at him, if you keep looking at Connor, I'm going to have to move you, brother. Because you need to be watching up here. Connor's not teaching the class. He's not going to teach you any math. I am. Compare is a, the question is a number greater less than or equal to another number. So when we're comparing, we're just finding greater than, less than, equal to. That's comparing. Is a number greater or less than or equal to another number? That's comparing in mathematics. Ordering in mathematics. No, Cole, it is not going to Sonic, pushing the little red button and go, oh, a chili coney, footlong coney dog thing with some tater tots and a Route 44 root beer. That is a type of ordering. You're right. Order your supper there. Good job. Not in math. In math, ordering means something else. So what do y'all think, or how can we put down a definition for ordering? And we can't say to put something in order, because you can't use the word order for the definition of ordering, because it still doesn't tell me what order means. Dad, don't give it a try. Okay. You're right, but I'm going to write it different. Is that okay? Ordering. Pudding. Not chocolate pudding. Putting. You writing there, Brother Will? Okay, there you go. Pudding, or sometimes called putting. Putting numbers in a certain over there. There you go. Putting, oh, I forgot S on my numbers. Numbers in a certain,
Sequence.
oh, what was it, Jones?
Sequence.
Sequence. Good job, dude. SEQ is our abbreviation for
Sequence.
sequence. To put things in a line. Now, of course, in this, I'm going to abbreviate this. What does that mean?
Largest to greatest.
Not really largest, but
Lowest.
least to greatest or greatest to least. No, it's not large and great. No, it's least and great. Okay? Okay. Now we got our definitions there. Now we got our definitions of what we're doing today. Shortcut goes to this down here. Okay. Let me do our little pizza thing. See if we can discover what's going on. I am comparing this pizza with this pizza right here. I want to know who has the most pizza left. In other words, which one is a bigger chunk of pizza than the other one. Okay? Well, how much is this one?
2/3.
We learned that last week. Good job. That's 2 1/3 pieces, which is just 2/3. Right, Tia? He hasn't been saying very much today, girlfriend, so that means I have to call on you. This one over here is what?
5 1/8.
5 1/8, but how do we write it?
5 8.
5/8. So I'm looking at and I'm comparing 2/3 versus 5/8. Now last week we learned things may look different, but they might be equal, right? They might be equal. These bad boys look different. I don't know if they're equal or if one of them's bigger than the other one. Well, if I got pizza, well, let's give it a good try here. All right, let me get all my pieces together here. All right, I laid my 1/3 right there, evened up with that right there. Okay, now I'm gonna line this one up and let's see what happens. Ooh.
It's slightly bigger.
Oh, I think 2/3 looks like it's a little bit more pizza, isn't it?
Yes.
So what can we say from what we visualize there? 2/3. 2/3 is greater than. Now we don't write the words greater than, we use the symbol. Alligator or Pac-Man or whatever you say, arrow, eats the bigger number, right? So 2/3 is greater than 5/8. Do we agree with that, Brother Haney?
Yes, sir.
All right, good. Come back from Peter Pan. Come on now. Come back from Peter Pan. You and him fighting over Tiger Lily again. Come on. All right. 2/3 is greater than 5/8 because we saw it visually. Now, folks, do we have time to cook a pizza every time we're dealing with fractions? No, again, we can't cook pizzas and cut them up to do fractions all the time. So we need a mathematical way of doing it, right? In this, there's a mathematical way and then a shortcut. I'm going to show you the mathematical way and the shortcut. And if you like the shortcut, let's use the shortcut, right?
Right.
But you need to understand how to do the other also. Okay? So Tony, if you can understand this, I'll let you do the shortcut. So, what we're trying to do without a picture is, can we figure out mathematically where the arrow is, which one's bigger than the other one or equal to, without having what?
Pizza.
Pizza. We got to be able to do it with math so I don't have to cook pizza all the time. Because Haney will get sick of pizza. All right. So, mathematically, here we go. Get the denoms denoms?
Denominators.
I don't know, but what is it?
Bottom.
Alright. Get the denoms, or the bottoms, to be the same. Get the denom, or the bottoms, to be the same. Well, that means I'm going to need 2 new fraction bars so I can put new bottoms down there, right? So underneath, put 2 new fraction bars. Guess what's coming back to haunt us? We learned that last week. Use PhD. Use PhD. All right, so let's think. Let's think together here. The 3 and the 8 need to be the same on the bottom. What can a 3 turn into and an 8 turn into and be the same thing? Is there a number out there they both can turn into that's the same number? What do you think, Brother Dylan? 3 and 8.
6.
No. 3 will make 6, but 8 won't make 6. That's all right. Good try.
24.
24. What do y'all think about 24? Will 3 make 24?
Yes.
Will 8 make 24?
Yes.
Okay, that's 1. Could we use 48?
Yes.
Could we use 72?
Yes.
So there's a lot of them out there, right?
Yes.
But let's use his, 24. So our new bottom is going to be 24. Our new denominator is going to be 24. Here's where we PhD. How did 3 turn into 24? Times 8. Where are we going with it now?
Top.
Top times 8. What's 2 times 8?
16.
Bam, there's a new fraction right there. So bam. You with me, brother? You doing this right here with me?
We have to write the fraction.
Yeah, we do. Oh, yabba. Yabba dabba do. Okay. How does 8 turn into 24? Times 3. Oh, what we do now?
Times 3 on top.
On top times 3. 5 times 3.
15.
15. Hope you are doing this example. Well, now I got new fractions. Look at numers. What's numers?
Bottom. Top. Oh, top of it.
Yeah, that was bad, all right. Look at the numers. Look at the tops. Look at tops. Look at numerators. Numerators. Which one's bigger, 16 or 15? Cole, which one's bigger, 16 or 15? 16. 16. I took it. All right. So if 16's bigger, what is our alligator looking like? You aren't helping me. How's my alligator? 16 and 15.
Oh, the 16, 24.
I know. I don't know which way to draw it.
Small point goes
This
to
way.
the 15.
The
Like-
point goes to the 15. His mouth opens to the big one, 16. Is that not what we got right there with our picture?
Yes, sir.
Same thing, but we did it mathematically. Okay? Now, we're going to do one more right here. Regular, then I'm going to show you the shortcut. Because I want you to understand how to do it this way, because we're going to have to do this stuff getting the same denominator when we subtract fractions. Okay? So we got to know how to do this. And on that far board, we're going to have to know how to do this. So here we go. 4 and 9. I can't tell which one's bigger. So we need what? Bar, new fractions, right? Y'all are writing this example in there in case it's on a pop quiz tomorrow. Right?
Yes, sir.
You got this written down. Brother Cole never written down. He didn't write number 3 down. No, he didn't. Over there, number 3. You're still blank right there in your notes. I see it. Number 3. When I'm writing on number 3, you should be writing on number 3 there, Coley. All right. We're trying to turn 4 and 9 into the same number. Aren't we, Michaela? 4 and 9 got to be the same down here. What can a 4 and a 9 both turn into, Craig? 36. Y'all like 36? What about 72?
Yes.
Yes.
Yeah, I like 72 too. But I like 36. So let's go 36. 36. All right. Now they got the same bottoms. All right. Oh, now we need to work on the tops. How do we do that?
Multiply.
Multiply.
PhD. So let's play. How did 4 turn into 36? Times 9. So go times 9 on his top. 27. We thought about it a little bit. Good. 27. There's our new fraction. That's going to help us. Right, Will? You're writing this down, aren't you, dude? Because it doesn't look like you are, buddy. Now, let's play over here. How did 9 turn into 36?
Times 4.
Times 4. Go to the top. Times 4. 7 times 4?
28.
28. Bang-a-lang. Rufio. Can you tell which one's bigger now? 27 or 28?
28.
28's bigger. My arrow eats the 28, points to the smaller. So there we go. Look at that. Are y'all okay with getting the same bottom and looking at them? You want the shortcut now?
Yeah.
Shortcut. You may remember this from last year with your teacher.
Yes.
Cross multiply. All right, but we got to do more than that. From bottom to top. Can't go top to bottom. You got to go from bottom to the top. Bottom to the top. Bottom to the top. Does it work over here with this one? Look at this. Bottom to top. 8 times 2.
60.
Bottom to top. 15. Is it still that way?
Yes, sir.
A lot quicker, isn't it?
Yes.
A lot quicker. I promise you, shortcut's quick, but we still got to know how to make the same bottoms now. PhD, okay? Keep that in there. Don't push it out. Does this one still work? Look at 9 times 3.
27.
4 times 7.
28.
28. Is it still that way?
Yes.
Sir.
So we come to a new one that we've never worked before. Will shortcut work?
Yes, sir.
Okay. 9 times 6. Oh, that's one of those hard multiplies.
54.
54. Good job. The other one is 10 times 5.
50.
50. Can you tell which one's bigger?
54.
Laka, laka. You going too fast, Connor?
No, sir.
Yeah, you hadn't written a thing in there, dude. Okay, good job. You already worked this one? Oh, man. How about this bad boy? 18 times 1.
18.
3 times 6. Oh, bacala. Equals?
Equal.
18 and 18. Those must equal each other.
Ew.
How? He's 18. 3 times 6. 18. What about the 18? Okay, well, you with me now? All right. So, do you understand this process using PhD to get the same bottoms? You understand that? Because you've got to learn that. We're going to use it later. Do you understand the shortcut? And just get her. Yes? All right. Come over here, girlfriend, so you can watch over here. Sit over there. There you go, my girlfriend there. Michaela's girlfriend. All right. Now, let's take a bunch of fractions and let's put them in order.
From least to greatest.
Or greatest to least, depending on what it's asking for. Now notice, do you see the word shortcut up there?
No.
Yes, sir.
Nope, ain't no shortcut on this one. So, let's just go through the tough old math. Tony, I'm up here. I've already written a word there, dude. Ordering fractions. If I want to put fractions in order from least to greatest, all right, get all denoms, which are the what?
Denominators.
Which are the what?
Bottom.
Bottoms. Get all the bottoms the same. How did we do that? You won't find it in the math book. Play how did. We got to get all the bottoms the same by play how did. So, let's come over here. Let's write down 3/5, 1/4, 1/2, and 2/5. And we're going to put them in order. The problem is, they all got different bottoms except for 2 of them. And I can't tell which is bigger. Now I can cook a pizza and take 3/5 of a pizza, and then 1/4 of a pizza, 1/2 of a pizza, and 2/5 of a pizza, and compare all of them, but that would take too long. How about we just all get the same bottom? Bar, 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 bar. Bar, 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 bar. Haney? There you go. Bar, 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 bar. Okay? What can a 5, a 4, a 2, and a 5 all turn into, and I'm going to go with Cole. Nope.
10.
10. A 4 will make 10. Cole, when we're done here, you can, okay, dude? Understand? Right now, we got to finish this, and you got to see this. How about?
20.
Oh, 20. Oh, you're both right. Good job. A 5, a 4, a 2, and a 5 can all turn into 20, can't they? So let's make our new bottoms all be 20, 20, 20, and 20. Right, Craig? Right, Connor? Here we go. At this point, what do we do that's not in the math book? PhD. Let's play how did. Okay? How does 5 turn into 20?
Times 4.
Times 5. Last time I checked, 5 times 5 was 25. How about times 4? 4. All right. So go up to the top and times 4.
12.
Our new top is 12. Right. Our new numerator. How does 4 turn into 20?
Times 5.
Times 5. Go to the top and times 5.
5.
5. Yeah, baby. How does 2 turn into 20?
Times 10.
Times 10 times 10.
10.
10. How does 5 turn into 20?
Times 4.
Times 4. Times 4.
8.
8. Bang. Here we go. I got 12 20s, 5 20s, 10 20s, and 8 20s. Can we find the leastest one?
5. 5.
The least one is the 5, isn't it? Where did it come from? 1/4. So 1/4 is the littlest. Don't need him anymore, do I? What's the next littlest one, Cole, up here? 5's no longer there. Which one's the next littlest?
8.
That's amazing, Cole. Your mouth never moved yet I heard something. That's a pretty good ventriloquist, dude. Cole, what's the next littlest one up here? 8 20s. Good job, dude. Where did it come from? 2/5. So I write down 2/5, and I'm done with that one. What's the next littlest? Dylan, what's the next littlest? 10 20s. Where, did you throw your voice again, dude? Or was that you?
I said it.
All right, good job. So 10 20s, where did it come from? Dylan, where did it come from?
Came from 1/2.
1/2. So I put down the half. Don't use him, and what's the only thing left? 12, and he was the 3/5. Okay? Now, class, on this one right here, what curveball am I throwing you?
Mix.
A curveball. Mixed numbers. But notice what the whole numbers are. 6, 6, 6, 6. That doesn't help me find bigger stuff, does it? They're all the same. So all I need to worry about is what? New fractions, right? And don't worry about the 6's, okay? We got to shut her down because we're at the end of class. Everybody understand? Haney, you okay?
I know what all the denominators.
What will our denominator be?
They all go to 24.
24. You are correct. We're not going to finish this, but they would all be 24s and with PhD, and then we could find the least, couldn't we? All right, kill it, girlfriend.